Welcome back. Today, basically, what we're going to be doing is we're going to be taking a look at the Boyle's law, and we're going to take a look at Charles' law. But to do that, we're going to use the kinetic theory of matter. Basically, I want to start out with what is the kinetic theory of matter. Kinetic theory of matter is the idea that everything is made of matter, and matter is in constant motion all the time. So if we have a solid, we have molecules, they're going to stay with their neighbor. They're not going to be switching neighbors. They're going to stay in a fairly structured format, but they're going to keep their same neighbors all the time. They're going to stay next to each other. Now, they're going to be moving. Kinetic is often called movement or the energy of movement. So these guys are just going to be vibrating back and forth, and they're going to be vibrating around, but they are going to stay with their same neighbors. Liquids are a little bit different. Liquids can roll over each other. They're all right next to their neighbor, but they can just migrate around. They can roll over each other, go all over the place. They have more kinetic energy. Now gases are just zipping around, bouncing off of surfaces, bouncing off of other gas particles, whatever. But that's in the kinetic theory of matter, sometimes called the kinetic molecular theory, or sometimes just called the kinetic theory. That's how solids, liquids, and gases tend to work quite often. Now, I do want to relate that to Boyle's law and to Charles' law, both mathematically, but also using the kinetic theory of matter. Now, Boyle's law mathematically says V sub 1 times P sub 1 equals V sub 2 times P sub 2. Basically what that means is if we have an initial volume at an initial pressure. Well, what happens if we change the volume? If we change the volume, the pressure is going to be changed as well. Let's pretend we have a volume. Here's a pretty little container right here. I'm going to put some gas molecules in here. We'll put 4 in just for giggles. Now those gas molecules, they're going to be zipping around in there, and they're just going to be bouncing around inside that container, back and forth all over the place, stuff like that. We have a volume, and now we have a pressure, because every time a gas molecule hits the corner of a container, that's pressure. That bouncing off, that makes pressure on that corner of the container. So we have a volume and we have a pressure. Now let's take a look. What happens if we change our volume, the volume of the container? I'm going to make my container smaller. I'm going to put the same 4 gas molecules in there, but I'm going to have a smaller container. Now these gas molecules, they're not going to go any faster, they're not going to go any slower. We haven't heated them up at all, but they're going to hit the walls of the container more often. Just because it's a smaller distance to go before they hit the walls of the container, it's going to hit it more often, and that's going to increase the pressure. So we could say, well, what happens if we decrease the volume of a container? The pressure will then go up. And the vice versa as well is true. If we increase the volume of a container, if I took this container and just made it bigger, it'll just be more time before the little gas particles get to the wall to hit it, so they're going to hit the walls of the container less often. So if we increase the volume of a container, the pressure will be decreased. So hopefully that gives you a little bit about how the kinetic theory of matter relates to Boyle's law. Now I want to take a look at Charles' law. Now, Charles' law, once again, we're going to start out with the math a little bit. Charles' law says V1 divided by T1 equals V2 divided by T2. Okay, that's saying we have an initial volume and a volume of a gas. Now, it really would not be in a container, but I like to think about it in an extremely highly flexible container. That just helps me be able to picture what's going on here. Okay, so we have gas in a very, very flexible container at a certain temperature or at a certain heat. Okay, now basically the question is, what's going to happen? What if we change the temperature? What if we change what's going on with the gas? Is that going to change the volume? And of course the answer is yes. So we have a nice little volume of gas, and I'm going to put the same 4 gas molecules in there, and once again they're going to go around and they're going to bounce off walls and they're going to make a pressure on the side of the walls. Okay, what happens if I heat it up? Now this is the best I can draw. Flame, that's really supposed to be fire, I promise. Well, if we heat it up, these gas molecules, they're just going to start bouncing around even faster. They're just going to go quite a bit faster. That's going to make them hit the walls of the container more often. Now, really, once again, I have to repeat myself. This is a volume, so really it's not even in a container at all. It helps me to be able to think of it as an extremely flexible container. Well, if these guys here hit the container more often, that's going to expand the container. That's going to make the container even bigger. And so if we increase the temperature of a gas, the volume will increase as well. And the opposite is true as well. What if we decrease the temperature of a gas? The volume will go down as well. So hopefully that helps you a little bit, relating Boyle's law and Charles' law and just explaining them and seeing how they relate to the kinetic theory of matter. Hope that helped. Have a beautiful day. Thank you.